Good morning. My name is Chen Francis Omondi. My supervisor for this paper was Dr. S.M. Musyoka, the Department of Geospatial and Space Technology. Hereby, I present a finding whereby I used GIS to find suitable locations in Kenya where a radio telescope can be installed, and by extension also setting up a radio observatory. This will be my presentation outline, whereby I'll introduce you to what I'm presenting, go further to the problem statement that motivated this study, give you the objectives, the criteria that I used, the methodology employed, and finally we get to see the results and have a discussion of the same before I conclude and also give my recommendation for furthering the study. We understand that astronomy has been defined as the study of objects that lie beyond our planet Earth. This object emits signals. If you check the electromagnetic spectrum, each and every wavelength can be used to study the outer space. So I am merging in now into radio astronomy, whereby I'm now using, we are going to use the radio wavelength of the EM spectrum to observe the outer space. So now why should we use the radio signals? This one is because we are able to accommodate other celestial objects like pulsars, which do not emit or reflect light. So we cannot use the optical wavelength, but they emit radio signals. So we are able to study them. And again, I also use GIS now, particularly to find which locations we can use radio telescopes, which are the primary instruments for studying the universe in the radio spectrum, which is a spatial systems that helps us to create, manage, analyze, and also map all types of data. Kenya is becoming, there is more activity in the country geared towards space activities. We are also seeing more of government commitment, whereby we now have a functional Kenya Space Agency domiciled in the Ministry of Defense. There is also interest from international bodies. We have the Square Kilometer Array, which is a global consortium that aims at having the largest group of telescopes with the largest baseline, so that we are able to observe the outer space with a more finer angular resolution. If we come back home, we realize that we have various locations that are dedicated to space activities. Notable among them is the Longonot Earth Station in Nakuru, which is currently defunct. It's been vandalized. There have been various suggestions that we refurbish the antennas at the Longonot Earth Station to a radio telescope. That is good. However, by use of geospatial methods, we cannot ascertain that Longonot Earth Station, as presently is, the location is suitable for hosting a radio telescope. That is what necessitated this study. The main objective of my study is I used GIS technology in a multi-criterion suitability analysis for finding suitable locations for hosting a radio telescope. And these are the objectives that drove me to my main objective, whereby first I had to establish a criteria for the same. Number two, I collected relevant geospatial data, and then I generated respective suitability maps before now merging and finding a final suitability map for the same. So I used 6 data sets, which I classified into anthropogenic and geographic. So my geographic data sets I used to wind speed, which the criteria was areas that experience lower wind speeds of less than 4.5 meters per second are going to be suitable. Wind speed, we understand it affects the pointing stability of a radio telescope. And then I also use the main electricity grid data. This because based on the geomagnetic movements of the Earth, some current is generated which are induced in our power lines. These ones in one way can be detected by radio telescopes, and they can come as noise, because by the time these radio signals travel from the outer space and they are detected here on Earth by a radio telescope, they are very faint. So as a way of minimizing that noise, so we have to find a location that is far away from the main electricity grid, which I used 1 kilometer. Again, it's rainfall. Remember, you know that in the outer space there is a lot of dust. These signals have to travel longer distances. They have to pass through dust particles, and again, rainfall. There is a lot of humidity and precipitable water vapor. This water vapor can cause signal reflection, refraction, or even it's attenuated. It loses strength. So if it is in an area that experiences high rain or high humidity per se, then we may not detect any signal because of such factors. So again, areas that receive an annual rainfall of less than 800 millimeters are recommended. Cell tower, these are the major issue in finding suitable location is radio frequency interference. We note through CIK studies that there has been an increased mobile penetration in the country in the last 3 years, with over 61 million subscribers in the last 2 years. So this one means that there is a higher, it's an indicator of higher radio frequency interference. We have, there is heavy penetration of the internet, mobile devices in the same. And RFI, this radio signal from our devices that we use cause a lot of noise. So we need to find an area that is free of that interference. So I had the cell tower data for the whole country. So areas that are 10 kilometers away from the cell towers are recommended. And then the DEM, this one generally gives the topography of the country. To enjoy natural shielding because of radio frequency interference from cell towers, TV masts, and any other man-made activities that we have, radars in our airports, and so on. Radio observatories enjoy best setting when they're in a valley. So areas that are below 1,500 meters above the sea level are recommended. And then another one data that I had was the land use and land cover data, which generally gives us what is existing on the surface of the land. So the data I had was from the regional center. They mapped the whole country and classified it into these areas, built-up areas, tree cover areas, cropland, vegetation, aquatic, lichen. Those are the least preferred. You cannot put a radio telescope in already a built environment. You know, the relocation costs, it's very expensive. So going to areas that are there are more suitable. This is the methodology. I collected all the data sets, both spatial and spatial. And then I did the data cleaning. And then also in the process of data cleaning, it was iterative. The data does not meet, it's not analysis ready. They have to be cleaned further. Once it's analysis ready, now we have to do the classification, the weighting, and then now we have to do the overlay analysis to get the results. I also use the AHP method, the analytic heuristic process for this. And then for each data set, I developed a suitability map for the same. And then now the percentage of influence as shown in this table, whereby cell towers, because of their indication of RFI, they have a higher influence as the same as the DEM, because radio observatory enjoy being shielded. Natural shielding is good for them. So they got a weight of 25% each. And then the land use land cover, 15, same as wind speed. And then now from the power lines, the rainfall, percentage of 10. The reason why these ones are lower is that you can apply correction from your analysis. If you already know, maybe by this time I was doing an observation, trained this heavily, so you can predict backwards by the time this signal left the source and came, how was it? So you can correct the noise levels in that. But for RFI, hardly can you do that. Now, these are my results. We realize that the red parts are the most suitable. The red star sections you can see, and then the yellow part, the section along Turkana, you can see that one is moderately suitable. And then the brown part is marginally suitable, and then this gray part is not suitable. And then there are areas that I didn't have data, particularly this part of Turkana County and subsections of Suitability County. Even this section of Lake Victoria and along the coastline. So you realize that several areas in our country that satisfy the condition where we can put evidence. Right? Some counties in Turkana, Garissa, River, Marsabit, Samburu, Mandera, and all that. Again, now, because there is this proposal of converting the long Earth station to a radio observatory, the antennas to radio telescope, you realize this blue part is where the long station is situated. You see it's in the gray part, not suitable. An explanation to that is because, with the development in our railway transport, the Naivasha Inland Container Depot is located just 4 kilometers from the port. And this one has spurred up a lot of human settlement and a lot of activities. Equally, again, there is a lot of now power lines there, the main bill that have to serve the ICT. So there is increased radio frequency interference. But now we cannot come up with an agenda that now let's relocate the port for purposes of this one. The relocation cost is so high. So by default, we cannot install a radio telescope in Norway. Then we have the Malindi, the Luigi Brodio Space Center in Malindi. This black section here. Again, it's not suitable. It's at the coast. It's set at the bay just inside the ocean. Because of the evaporation, it also suffers higher humidity reports. And we know what this does to radio signals that come from the outer space. So then now we can only go with other options that lie in other counties. Of importance to note is that some of the counties that are suitable lie touch on the Kenya's outer boundary. It is not advisable to put a radio or secretarial radio telescope in counties that are on the outer boundary like Mandera, Turkana, Garissa. This is because of very many reasons. Key among them is one, national security reason. Remember, radio observatory is a critical national security infrastructure. Number two, there may be varying anthropogenic conditions in the neighboring country that you as astronomers within your own country you may not have gone to know. You cannot even gazette a radio quite soon. So to be in a safer space of operation, it's somewhat good to be just within your country. Some very good mileage from the boundary. In 2005, there was a proposal that was made by Mr. J. Oval of the University of Nairobi to set up Kenya International Radio Observatory. Yes, yeah, it's Professor. Yes, I am. Well, if you're listening, I'm sorry, it was not my intention. Professor J. Oval. So they came up with a proposal to develop Kiro. But now they stated in their proposal that this radio observatory should be set up along the equator and, if good, on the northern part of our country. Through this study, however, they never stated the methodology they employed to propose that part of the country to be suitable for that. But through this study, we are able to see that, yes, if I zoom in, we can see Samburu County satisfies that condition. There are some sections in Samburu County that satisfy that condition of having it. And now this one is by use of geospatial methods to find that place. Another thing is that the other issues that I mentioned that may not be suitable if you select a county that touches on the boundary is the issue of security, national security, and also the varying condition in the neighboring countries. I did not factor that in my study, so that one forms now a part of the recommendation of furthering this study. As I conclude, the data set I employed were the national center data, national electricity data, rainfall, land use, land cover, wind speed, and also the slope which I generated from the DEM. I used S3's ArcGIS software for the analysis. I used the multiple attribute and decision-making process of MCD and GIS to be able to find these sites. And then we just need to avoid counties, areas that touch on the outer boundary. Further, this study, because it is the best study for radio astronomy, finding suitable location for hosting a radio telescope. It is good that further RFI analysis be conducted in suitable sites. Again, wind gradient analysis should be conducted further to find the exact one that does not experience higher wind speeds. More suitabilities now to include more data like atmospheric dust, which by the time I was doing this study, I wasn't able to find it. And this one brings me to the end of the presentation. Thank you so much.
Thank you, Francis, for your wonderful presentation. Maybe you can quickly talk on the efficiency of your proposed method versus the cost implications. I didn't hear you mention that. You can quickly highlight the efficiency of your system versus the cost implications of your proposed method. That's the global information systems.
GIS as a tool and as a technology has come in handy to help man be able to make decisions, particularly on land suitability. The reason for this is that through a GIS, you are able to incorporate various on the study of land suitability, very many data sets, voluminous amounts of data is involved, whereby you need to find just a small niche of it that may be applicable for whatever you're looking for. So now GIS tool gives you that efficiency. You just bring in the data that you want, the criteria, and you proceed with the analysis. So now, and then these teams, there are those that are commercial and others small teams. You can as well go ahead.
Now,
What is the criteria? You are not taking into consideration the utilization. Why is it not part of the astronomy? And yet, here, for the beginners, they have very little so, thank you. What is the development right now was established now regional storm?
Thank you. Allow me to respond. First, on the criteria, there are guidelines that are given on whatever parameters you should consider. But we have to note that not all countries, not all regions of Earth experience the same geographic conditions. So we'll realize that countries like Malaysia, for them, when they were looking for a place to site their radio telescope, they only used cloud cover and RFI, correct? Because their reality is different. When you go to, for instance, like Ghana refurbished their version of our long road to a radio observatory. I happen to visit the site as well. So we also use a different parameter. So there are guidelines which highlights extremes that you should not go beyond certain values when you are looking for this, for you to be able to find a good location to sit. And these guidelines, there are some are developed by the International Telecommunications Union. The essence of this is one, whereby there is need to do an observation by using the VLBI, the very long baseline interferometric network. If your site adheres to that, it's very easy to incorporate your antennas to observe a particular section of the sky to see what is happening, what objects are observed. Yes. The other one is the issue of the equator. For us, we are happy because the equator is like the center. So we are able to observe whatever is happening in the northern hemisphere and the southern hemisphere. Now that's the advantage that we get to enjoy. And then on the issue of Malindi, a lot is going on in Malindi space station. However, we must note that the issue of Malindi is a tripartite agreement of government to government, the government of Kenya and the government of Italy. So it has been used previously for rocket launches, and most recently it was used to pick the first signals of the James Webb Space Telescope as it was its maiden voyage of 1.5 million kilometers to the outer space to observe the outer space for us. So yes, it's still it's operational, a lot is happening. Probably we may say about the issue of now public communications for it, whatever is happening, the relevant agency mandated to do that. They now need to farm and come up with more aggressive public communication so that others Kenyans will also get to that. So what is that going on? Because in the space, the global space community, Malindi is among those ones that are regarded and all this. And then as I conclude, when it comes to astronomy studies and the global space community, space activities, it happens as a unit, A rocket might be launched from California, but for us to send a command maybe on its route, it's not aligned to whatever antennas that can follow us. We have to know maybe 10 for us to use our equipment to send that command to the locators. It is on its part of there. So there is that essence of operation. Yes, thank you.
There are more questions online. How did you calculate the weights of the different factors affecting radio observations? How did you calculate the weights of different factors affecting radio observations? Number two, how quickly does the effect of a power line decrease with the distance? How quickly does the effect of a power line decrease with the distance? Lastly, was a background study done in relation to other countries in Africa, like Ghana and South Africa, on how they arrived at a suitable location for their radio telescope sites for comparison purposes? Was a background study done in relation to other countries in Africa, like Ghana and South Africa? Quickly, you can respond.
Thank you so much. I don't know who asked the question, but let me just say thank you. Then the name received. So now, how are the rates arrived? During this study, I consulted a radio astronomer who guided based on priority on various factors and various data that I had from the study around which affects the study. And then we know the power line. This induced currents outside the main grid that are able to be detected by the radio telescope. So the farther you are from them, the better for you. Because if you are closer to them, you are anticipating noise, and it will be very hard for you to do the correction. You may not even see it as you observe your readings. You just see some things and you think it's normal. Maybe it's noise. Probably when you go further into analysis, you don't perceive. And then on the issue of the background for the observation, yes, the South Africa, for instance, being the pioneer of the square kilometer, they upset with their radio telescope. Taking it in a desert, very far from urban areas, purposely for that, to avoid radio frequency interference. Also, the region is not as skewed, it's very dry, so the signals can be well reached. If you observe the Ghana observatory in Kotobusi, they converted the version of earth station for purposes of understanding the antennas to a radio observatory. However, what is important to note is that there is considerable human settlement in around the space station. So you find you may realize that now the antenna will not be effective when we now want to do interferometric VLBI observations, rather with several antennas on the globe need to observe a particular thing. Because now the antenna will give a lot of RFI, and you know where people are, they have mobile phones, Wi-Fi, and all that kind of things. Yeah, thank you.
Thank you. We can give him a clap. The question came from Francis Omundi and Samuel Nyanki. We have talked about big data sets and trying to find the best location. You can think of machine learning, artificial intelligence, added to GIS. It will be a very interesting topic. So further study. Thank you. Next, we have Martin Wanche. Martin, you can hear me? Martin?
Yes, I can hear you. I don't know if you can hear me.
Yes, I can hear you.
Okay, maybe.
Hear you.
I don't know. I sent the presentation. If you can present for me, or I can present from my side.
I think it's better you present from your end because you can be able to scroll.
Okay, fine. Let me do it. Sorry for this. I was.
No problem. Go ahead. After Martin, we can have the keynote speaker. So Martin, quickly, kindly present your slides. You have 8 minutes. and 2 minutes for questions.
Now, where's this presentation thing? I'm looking for a presentation icon. I don't know what it is. Please, in assistance, presentation icon.
There is the share screen.
Yeah, I've seen that. Okay.
Okay. Put it in slide mode from the beginning. Okay.
Okay, I think you can see my screen.
You can be able to
Hello?
see it. You can go ahead.
Okay. Good morning.
Yes. Morning. Go on.
Yeah. Okay, fine. I'm Martin Nanja. I'm presenting a topic on a survey that I'm doing. These are the few papers I'm working on. I'm a PhD student at the University of Nairobi Department of Environmental Biosystem Engineering. My supervisors are Professor Ayub Chao and Dr. Duncan Buke. I'm sorry because I wanted to present it online, face to face, but I had another presentation at Kisumu. We did a consulting engineers conference, so I rushed there to do a presentation. Sorry for that, but maybe it was planned like that. So my topic will be a baseline survey on current mechanization. I'm doing a research on potato harvesting technologies and handling. That's my topic. So the first thing I went is to do the survey on the mechanization part of the potato and the labor-intensive activity, so that at least we can understand which activities being labor-intensive in a potato production chain. So my case study is in Nyandarua County. I chose Nyandarua because of the level of production. Nyandarua is the most potato production county in the country, producing about 3% of the potatoes in the country, which is around 33% of the potatoes in the country. So I'll start. So potato has become a significant food crop in sub-Saharan and even the world, because I was in Russia and they were eating potatoes, and every part of the country they are using potatoes both for consumption and for cash, for consumption and for the income source of